Hello everyone, my name is Deniz. I am a PhD candidate at Istanbul University. During my master's, I work on the origin of the metal poor stars. I will talk about a simple but interesting question. What is the very old metal poor and high velocity star doing in the solar neighborhood? These stars are not expected from here, so they must have come from somewhere else. In this study, we investigate whether such a star could have originated from globular clusters and later reached the solar neighborhood. To explore this, we combine different methods and datasets, including the spectroscopy, photometry, astrometry, kinematic, and orbital analysis, and compare the stars and 170 clusters in the Milky Way. First, I would like to introduce the Galactic Structure Research Group. It's a research team based at Istanbul University, collaborating with many international partners. We are involved in a wide range of projects. If you're interested in stellar astrophysics, feel free to scan the QR code to reach out of us. In this study, we used multiple methods, so we did not really the single dataset. For spectroscopic analysis, we used the LOG archive. For photometric analysis, we used the latest Gaia catalog. In addition, since we perform spectral energy distribution analysis, we use photometric filters covering a wide wavelength range. To perform for analysis, we use the Ariadne code. Using the Bayesian approach, we hit different photometric data points and compare them with theoretical model atmospheres. The best fitting model provides the stellar parameters. On the left, you can see example of fitting. The blue points represent observed photometric values, while the open purple diamonds represent the model values. For the spectroscopic analysis, we use the mu code in the LTE assumption. The methodology we applied are described in the detail or previous publications. Now, I would like to highlight an interesting question. Where these old metal poor and high velocity stars in the solar neighborhood came from? We not expect them to be here. Could they have originated from clusters in the Milky Way? To answer this question, I will introduce a few simple scenarios. To explain these scenarios, let's consider a simple case, a cluster and star. For clarity, I defined 4 different scenarios. In the first scenario, the velocity difference is small, around 10, but the positional separation is high. In the second scenario, it's different. The positions are close, but the velocity difference is high. To better explain this, I prepared more detailed illustration. Let's take a closer look at third scenario. The radius of the cluster extends to about 5 tidal radii. To distance to the stars is about 6 tidal radii. This means the stars lies outside the cluster, so the probability is low. In the fourth scenario, the stars move closer and enter with the 5 tidal radii. In this case, the positional probability becomes high. Now we applied this scenario to real data. We used 170 clusters in the Milky Way globular cluster. The probability of the star encounter with each cluster was calculated over 3 billion years in the 5,000 years increments. So let's check the graph. The colors go from the blue to red. Red high probability, blue low probability. Each row represents globular clusters. As a result, the possible cluster of 4 our stars appears the first one. We will present these details in the article. So how do stars escape from these clusters? Let me briefly explain that and I will finish. In this figure, the red orbit represents the motion of the globular clusters. Stars can escape from regions with the cluster where the gravitational binding is weak due to interactions with other stars. After escaping, Their orbits can be altered by the perturbations of the galactic bar. Along them, travel outward, eventually reach the solar neighborhood. They may even pass beyond the sun. Finally, I would like to mention a relevant study. Analtash investigates red giant stars in the Rave survey and studies how stars can move from the galactic center to solar neighborhood under different gravitational potentials. They show that if we know a star's maximum vertical height, orbital eccentricity, and pericenter distance, we can understand the mechanism of affecting its motion. We found that our stars consist with this scenario. Thank you for listening. You can scan the QR code, check out my published papers, and feel free to email me if you have any questions. Thanks again.